think that this is the first year I've ever heard CS majors talk about sports at all in the actual class, so yay. I mean, I love a variety of things, including sports, so anyway. To where we left off last, so I mean, if you ever want to talk science fiction, Star Wars, Star Trek, whatever, we could do that too. But anyway, we left it off last time looking at for loops and a little bit of a new syntax. Where, yeah, there we go. All right, it's working. And what I wanted to do first is to go back and look at that basic loop once again. I've changed it here to 5. I want to take this opportunity to show you yet another useful tool. This is a code visualization tool called Python Tutor. It's called Python Tutor, but it supports many languages. In particular, it supports C, and that's what we're looking at right here. We could, of course, look at the same thing in Java, but it's going to be exactly the same. So take a look at this. I've got an n variable here. That's what I'm going to go up to, but not including. This is, once again, an idiomatic for loop. You will get so used to writing for loops like this that it'll just become second nature. We start at I is 0, and we go up to, but not including n, and then I++ over here. Each time we're printing it out. And so you can watch and see what happens here. I've got a variable n over here. Right now, big question mark. Why? Because it hasn't been assigned yet. Only when we get past line 3 does it end up getting assigned. Before we do that, I want to go back here. On line 3, does the variable I exist yet? No. Right? And you can't see it over here. Right? That's called scoping. That's something that we'll talk about here in a moment. Now there's I, because we've entered this for loop. We haven't yet executed this first initialization statement, but once we do, we see that it has a value of 0. This evaluates to true, and we end up printing it out over here. Uh-oh. What did I screw up? If I had run this with the wall flag, it would have really caught it. But I don't have the wall flag here. Actually, I do. It is warning me down there, right? Apparently they are running the wall flag. So what have I done wrong with this print statement? I is equal to %d. What am I actually printing out? Nothing, right? So let's go ahead and edit this code. You can go back and forth with this tool all you want. And let's actually go ahead and print it out there, right? Now let's go ahead and visualize this execution. I will go ahead and fast forward to where we were before. On the first iteration, we're going to end up printing out 0. There we go. Now, what value does I have right now? We've come back up to the loop up here. We have not yet incremented. The increment can be seen as being done after or at the end of the loop or before the second iteration of the loop. And we increment it to 1. Right? 1 is strictly less than 5, so we end up continuing. Right? 1, there we go, dot, 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 dot. There we go. Okay. So when did we finally break out of this thing? I was 4. Now it's not showing it, but I received a value of 5. 5 is not strictly less than 5, therefore we broke out of that loop. I want to edit this code one more time and show you what happens. Well, it's not going to compile first, but let me go ahead and print out I at the end of the loop. Predict, should I be able to do that? Right? Where does I exist? Right? In the loop. Why? Because I declared it right here. I'm going to go ahead and try to compile this, and you'll see that I is undeclared. Right? Why? Because I is only within the scope of this for loop. What does scope mean? Well, if you take a scope, like in a submarine or something, and you only look through the scope, can you see everything? No, you can only see what's within your little viewport right there, right? And so the scope of a variable is the area of code that it exists. Everything else, it doesn't exist. For example, I did not exist on line 3. It does not exist after line 6. We have limited the scope to only that for loop using this syntax. I could have done something different. I could have done something like this instead, int I. There we go. Now it will compile because I exists before on line 4, and therefore it's not scoped to just the for loop. Close that. And it exists after that for loop. So let's go ahead and continue running here. Right? Dot, 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 dot. 1, 2, 3, 4. 4. We come back up, increment it to 5, but that's what breaks us out of that for loop. I print it one more time to prove that it indeed has the value 5. So you might be asking yourself, okay, well, why should we limit it to just the for loop? Generally, that's the best practice. You want to limit the amount of side effects. You want to limit the amount of where your variables are. You want to limit the scope of your code as much as possible in general, right? Why? Because you want to limit the number of failure points. Remember I had that analogy that the bridge doesn't collapse if there's just one bolt missing, right? Well, that's called a failure point. If you have one failure point, okay, fine, right? If you've got 2 failure points, 3 failure points, potential failure points. And it's not necessarily going to fail at those points, but if you have 50 different failure points of possible failure, right, that's not as good as having just 1 or 2 or 3 points of possible failure, right? Of course, the 50 failure points could be that it always works, right, and it never actually fails. But you want to limit the number of potential failure points. And limiting the scope of variables is exactly how you do that. Now, before we continue, I do want to show you a similar visualization tool over here in Java. And let's go ahead and write that same for loop over here. But it's going to be way more useful over here in Java. You can have something like this. We'll look at it later. It's called a debugger in both languages. Int 5 for int I equals 0. I is less than n, I plus plus. Right? Printf. System.out.printf, I is equal to %d and the line, I. Actually, let's see if it compiles here. Hopefully it compiles with a warning. .out. There we go. Okay, yeah, wonderful. Now let's see if that actually runs. Nope, it's going to be, oh no. There's some sort of a bug in my program that has resulted in this error here. Now, we know what it is because this is simple enough code that we can just look at it and say, yeah, it's right there. I didn't print out the I, right? But if you've got much more complex code, you'll want to enter into a debug mode. Now, what I just did here is I set a breakpoint, kind of like what was happening over here in the visualization tool. Right? The visualization tool can be used as a debugger if you want, but there's a much better debugger that I'll show you later on. This is the debugger. So if you come up here in Eclipse, if you come up here to the play button, right next to it is this little icon. What does it look like? It looks like a bug, right? It's got 6 legs and a head and antenna, right? So let's go ahead and debug it, right? I will switch to my debugging perspective. Now over here, I've got all these variables listed, right? So there's my arguments. Don't worry about that. But you can expand that out and see that the first argument is 10, the second argument is 10. For whatever reason, I had arguments there before. But you can see that the execution is paused, just like that visualization tool, right? I'm now on line 12 because that's where I set this breakpoint. It'll run my program up until the first breakpoint. I can continue it, play here, continue, resume, until the next breakpoint if I want. I can stop it entirely, or I can step through it line by line, which is what I'm going to do. So step through to the next line there. Hey, what appears now over here? N, which is 5. Cool. Let's go ahead and step one more time here. Right? I now exists because we're inside the loop, and you can see that it has a value of 0. I will continue to have that highlighted as I step through, and we can see, okay. Oops, I don't want to step through that. Darn it. All right. Okay, no, there we go. Now we see that it actually happened at that line, right? That tells me that something happened there. I can back up, I can run this again. It'll go up to that breakpoint, and I know, okay, there is definitely something wrong with this line. So let's stop it and fix exactly what it is. Right, there we go. I need to print out I. And now let's go ahead and run it again in debug mode so that I can witness it. Right? Step, step, step. Right? There's the first iteration. I is now or printed out 0, but it's still 0 here because we've not yet incremented I++. Step, oh, hey, it changed. 2, 1. Step, printed out. 2, step, 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 until you get down to the end here. Okay, it's perfect now. Right. This is a debugger. How do you do this again? Well, I'm going to go ahead and change my perspective back to Java because this is what most of you are probably at. But it's the little bug up here. You can set breakpoints and unset breakpoints by double-clicking over here off to the side, right? Double-click it and it goes away. You can have as many breakpoints as you want for each line, as long as it's an executable line. Let me go ahead and undo, undo, undo. We'll look at much more sophisticated ways of using this debugger later, but you should know that you have this tool in your hand. You can actually, you don't, this is what you would generally do as a beginner is that you'd do what's called poor man's debugging, where you'd just simply, like I'm doing right here, I'm simply printing stuff out. All right, it's good up to that point, it's good up to that point, right? No, that's very, very error prone and brittle. Right? Using a proper debugger will get you down to the nitty gritty of what's going on. Right? All right, that's a preview of debugging. We'll have a full unit on that later on. Otherwise, to remind ourselves of the new syntax here, right? We've got I++, which adds 1 to the variable I. We've got I-, which subtracts 1 from the variable I. You can do this by other values other than 1, using plus equals. You can do it with subtraction. You can do it with multiplication. You can do it with division. But what was the issue there? It is integer division. Right? So if I take 10, divide equals 3, what will I end up being? So 10 divided by 3 will be 3.333, but integer truncation gets rid of that, making it 3, exactly. All right. So that's a for loop. Well, we also have while loops, right? A while loop uses the keyword while. Who would have thought, right? Main difference is that the 3 elements are separated, giving you a bit more control. Right? And I'm putting that into quotes there because it's not actually control. Here's a little secret. You can take any for loop and you can translate it into a 100% equivalent while loop, and vice versa. You can take any while loop and you can translate it into a 100% equivalent for loop. We'll discuss when it's appropriate to use one versus another. It's a little bit more art than guidelines I can give you, but they are different, right? It's a little bit more flexible. It is a little bit more flexible. Right? You can place the increment anywhere in the loop, right? So let's come over here to, I don't know, let's just do it in Java, right? And I've still got my n here. Let's go ahead and translate this entire for loop here into a while loop. While I is less than n, I will do the following. Right? Now the problem here is this is my continuation condition. What was the first thing that I needed to do? The loop's got to start somewhere. So I need an initialization condition. Int I is equal to 0. Right? So rather than scoping this directly into the while loop, right? You can't scope a variable without a control variable, I should say, in a while loop just to the loop. So that's one difference. Right? You can do that with for loops, but you can't do that with while loops. So I've got the initialization here. I've got the continuation condition here. Note that it uses the same parentheses, the same opening, closing curly brackets, etc. Right? But what if I run this right now? Am I making any progress towards that terminating condition? Nope. So infinite loop, stop that. Right? Let's make progress towards that terminating condition by going I++. I'm doing it at the end of the loop as the last thing inside the loop. And that will lead to an equivalent 1, 2, 3, 4, 0, 1, 2, 3, 4. But here's where the flexibility comes in. You can take that I++ and you can move it up here. You can do it at the beginning of the loop. Now predict, remember before it was going 0 through 4, predict now, what is it going to end up printing out? I is 0. What's the first thing we do before we print it out? Add 1. So the first thing that gets printed out is 1. 2, 3, 4. Does it print 5 or not? Let's find out. Remember, once it's 4, it gets printed out. Come back up here. Is 4 strictly less than 5? Yep. So what's the first thing we do? Ding, 5. And it ends up getting printed out here. Run that again. And we're just off by 1. In fact, this is the most common type of error with loops, being off by 1. Sometimes you have to deal with the first iteration separately. Sometimes you have to deal with the last iteration separately. Sometimes you can roll those in and not be off by one. Let's fix up my, you can, that's the default formatting there for Java, to put spaces everywhere. I generally like this instead. I do like spaces here, but there. If you want to, whatever you want to do, whatever habit you want to get into. There is zero difference between a while loop and a for loop versus a while loop, for loop in C. Exact same syntax everywhere. Right?
Is that universal across basically every language?
No, because there are not traditional idiomatic for loops in, say, Python. There are while loops in Python, have the same basic behavior. There are do while loops that I omit entirely. Some languages have them, some C and Java have them, but I don't know. Pythoners, are there do while loops in Python? I don't know. Let me know. Google that and let me know. Right? But in any case, you will have basic for loops and basic while loops in pretty much any language.
Yeah, the answer is yes.
Oh, there is a do while loop. Okay.
There are do while loops.
Gross.
Yeah.
Anyway, remember, if you've got an infinite loop, you can kill it in C with Control C. In Java, in Eclipse, there's just that stop button. Right? You can scope a counter increment variable to restrict it to a while loop. You cannot do that like you can with a for loop because it is declared before the loop. Consequently, regardless of how you do this, I is going to exist in a wider scope with a while loop than with a for loop. Right? So there, it's still 5 after I break out of this while loop. Right? There's no way that you can restrict I, that particular variable, to the while loop. You can declare variables inside. Int a is equal to 42. Right, there we go. Right, and now the existence of a only exists, the scope is only to the loop, but that's because you declared it in the loop. In fact, you redeclare it on every single iteration. I will be lost at the end of this loop, and a new I will take, or a new A, excuse me, will take its place. So that is possible. Okay. Again, the formal definition here is that the scope of a variable is the section of code in which it lives, or is it valid. In general, it is best practice to limit the scope as much as possible. Right? So when you write a for loop, definitely always write for int I equals 0. If you've got multiple for loops, fine. One I up here, one I up down here, one I down there. Right? Make sure that they're scoped to only that loop. Yeah.
Could you explain to us again, like the case where we're off by 1 at the while loop? Like
Sure.
how that works? Because
All right, let's go ahead and get rid of that. Let's understand it by actually running through the debugger and see what happens. Oh, I need to set a breakpoint. There we go. Yes, switch. That's a perspective up here. Here's a debug perspective because it's got the bug there. You can go back to your Java perspective over here, but I'm over here. So let's go ahead and step, because now we've got n, which is 5, and I, which is 0. N is not going to change. All right. So is it the case that 0 is strictly less than 5? Yes. So we go into this while loop. The very first thing that we do, though, is increment that I to 1. Right? And then we print it out. Okay? And so now down here we've got it printed out. I'm going to go ahead and step. 1, 2, 3, 4. There we go. Now what are we about to do? 4 becomes, now we're on line 15 here. 4 becomes 5, and we end up printing it out. Right? Now, is it the case that 5 is strictly less than 5? Nope. So we end up breaking out of the while loop and ending. Good? All right. Anytime you need a refresher on this stuff, just run a debugger, right? By the way, again, you can, let me go ahead and put in a bunch more lines here. Hello. I'll say hello. There we go. 1, 2, 3. Yeah, we'll restart this. I'll set a breakpoint right here. And, okay, I know that everything's okay in this while loop. So I'm at this breakpoint, but I'm stopped. You can always continue, and it'll immediately jump to that next breakpoint. So if you've got a loop that runs for 1,000,000 iterations or something like that, and you don't want to sit there and go next, be judicious about putting
Auto
where,
clicker.
yeah, definitely not even an auto clicker, or grinder or whatever you call them. Go ahead and just set up a new breakpoint and run to that next breakpoint. Stop. And Java. There we go. All right, so now that we have these two loops, again, I'm intentionally omitting do while loops. If you want to, read the book about it, look it up. Basically, a do while loop allows you to execute the loop once, regardless of the continuation condition. And then the continuation condition is checked at the bottom of the loop instead, at the end of the loop. Right? I'm only going to cover while loops and for loops, and for each loops in Java, but we'll talk about that here in a second. Right? So observation. Any while loop, in fact, while loop, can be rewritten as a for loop and vice versa. Right. So why two? Well, a programming language is like a language like any others. Right? Do we have just one word for nice, good, beautiful, whatever else you want to do? Yeah, no, we've got a rich language, right? We've got different words with different connotations, different situations in which you want to use them. It makes a language richer, it makes it more usable, and it makes it more, just better, right? Likewise, a programming language. If you have two of these things, two of these constructs, you could always get rid of one of them. You'd only need one. Right? We're only ever going to do for loops. We're only ever going to do while loops. But it makes it a little bit more flexible, right? So why two? Because it makes the language richer. So in general, again, this is not a rule or anything that I can give you. If you're told to write a for loop, write a for loop. If you're told to write a while loop, write a while loop. If you're told to write a loop, do whichever one you want, but here's the general guideline, right? While loops are used when you don't know how many iterations up front. We have a technical term for that, a priori. Up front, don't worry about it though. How many iterations it will run for, right? In other words, it depends on some variable, right? Or expression. There we go. And I'll show you an example here. In fact, here's the example. Write a loop to compute the number of digits in an integer. So for example, if I have 1, 2, 3, 4, 5, has 5 digits. 0, careful, has how many digits? 1 digit. Negative 123 has how many digits? 3 digits, right? There we go. So we've got several examples here, and we've got to write this code now, okay? Help me out. I'll go ahead and put into n here 1, 2, 3, 4, 5. I will also create another variable here, int num digits, and we'll start it out at 0 here. Right? I want to count how many digits there are. 1, 2, 3, 4, 5. Done. Well, if that input is read in from the user, no, that's not going to work, because the user could enter in that, right? The user could enter in 1. It also has 1 digit. So that's just a test case for us to get this code started. Right? How would you go about doing it? Yeah. Okay. What will the result be for 1, 2, 3, 4? 0.5, but then, or 4, that begins 1, 2, 3. Okay. Okay. All right. Then it becomes 12. Dot, dot, dot. As you observed, when I divide, say, oh, here, I'll just go ahead and say that it goes to then 1. And then 1 divided by 10 will be 0.1, which integer division, truncation, will end up being 0. How many 1, 2, 3, 4 lines did I write? That gave me my answer, right? So, it's now I just did this in code here, but what you would want to do is whiteboard it, right? That's what we do all the time. This is why we have whiteboards, right? So that you can write your ideas out here, write them on a piece of paper. We like whiteboards because especially if you've got a partner with you, or a pair, you're teaming up in a pair trying to solve a problem, you can see a common whiteboard here and you can bounce ideas off of each other. Right? If I were whiteboarding it with you, I would have written it up here on the whiteboard instead with an actual concrete example. Always start with a concrete example and then generalize it. Right? I'm not always going to have 4 lines that I divide. Instead, I'm going to say while n is not 0, I will divide it by 10, right? And count another digit. Again, that's my whiteboarding. This is not code, but this is what I would have written up on a whiteboard. This is pseudocode, fake code. Right? I'm just outlining my ideas here. Right? Now let's go back and actually translate it into something that Java would understand or C would understand. It's going to be the same in both languages. I will be able to literally cut and paste this and put it into C. Right? So while n is not 0, not equal to 0, what will I do? Or did you say not equal to 0 or greater than 0? Okay. You're jumping immediately to the conclusion. I would have started with so that I could demonstrate what happens when we got negative numbers. Right? You'll never get there. Right? We'll come back to that though. While n is not equal to 0, divide it by 10. N is equal to n divided by 10. Is there a better way to write that now that we've got that other syntax? Divide equals 10. There we go. And then count another digit. Num digits is equal to num digits. Now you see why we've got plus plus and I don't have to rewrite all this crap, right? Rewrite that as plus plus and you're done. All right. Let's go ahead and print out the result. Printf, or system.out. %d has %d digits. Digits, there we go. And so I will print out n and num digits. Okay. Yeah, oh, thank you, F. There we go. All right, let's run this. 0 has 4 digits. All right, careful. What was if I wanted to print this out? What was the original number? 1, 2, 3, 4. Right. If you want to preserve that, then you need to make a copy. Int original is equal to n. Or change it around so that you're using a different variable. Original. There we go. Now I've got 1, 2, 3, 4 has 4 digits. Okay. Done. Ship it. Is that enough testing? Just testing one number? No. We'll get into more formal unit testing in the next couple of weeks after your first exam. But formal unit testing is setting up a whole bunch of tests. This is exactly how the grader works, by the way. Right? Yeah. So in week 5, we'll have more information later, but it'll be programming exercises, exactly like not exactly, but pretty much like a hack. No partners or anything on it. It has to be your own. But open book, open note, because it's required computer, because you're writing code and submitting code to CodePost. Resubmit it as many times as you want, right, up until the due date. So back to unit tests. Right? I'm not doing unit testing here because that's a formal framework that's required. What I'm doing here is ad hoc testing. Ad hoc means as needed. Right? I'm just doing a sanity check right here. What if I added one more, 1, 2, 3, 4, 5. What if I added one more digit? I would expect that to be 1, 2, 3, 4, 5 has 5 digits. It works. Done, ship it. 2 is enough. 3 is enough, 4 is enough, 5 is enough. Is there ever enough? No, because if you have an infinite number of numbers, how do you know that it works for an infinite number of test cases? Right? So you only have a high assurance. I could have like 10, 15, 20 test cases, and I'm pretty sure I've got like 99% code coverage. I've got, or 100% code coverage. I've got a 99% assurance that it's correct, but I can never actually reach 100, right, without a formal proof. And even then, you have to have a proof that your program, as a formal proof, is correct as well. And then you need a proof for that, and then you need a proof for that, right, et cetera, et cetera. So it never ends. Right? All right. Unit testing also requires you to look at a variety of inputs. only looking at positive numbers, big and small, that's not enough. What else should I be testing? What did I identify over here? Negative 1, 2, 3 has 3 digits. So does that work? Okay. Done, ship it? No, you need to test some corner cases here. Corner cases or edge cases. If you were to say, okay, go over to calculus or whatever and say, oh, 1 divided by n, oh, that works for everything. What does it not work for?
0.
0. What happens at 0? Yep, it goes down to, or it blows up to negative, positive infinity or negative infinity, depending on where you're coming from, right? That is that's not a critical point. What is it? It's a discontinuation. What is it called? Well, it's not the where it blows up. It's a
Syntax.
it's not a continuous function at that point. I don't know. It's a discontinuous point though, or discontinuity. Okay. Ask your yeah, ask your calc professor what you would call that, right? But anyway, what happens at 0? It should have 1 digit, but it doesn't. So remember, if you're off by 1, right? Maybe some corner cases also need some special tests here. Right? For example, if I were to say, write down if bad things happen at n equals 0. So if n is equal to 0, then we can say, we'll print out, I'm just going to steal this code here. There we go. Has 0 digits. Or in fact, here, let me just move this up here. And I don't have to accommodate that. Has %d digits. There we go. Original, and I can move that up there as well. There. And then I'm done. Otherwise, and I don't need this, there we go. There. Code optimization, right? And now it will work for that one. I changed my code. What should I do? Go back and test everything that I just did. How do I know that I didn't break it for 1, 2, 3, 4? Right? Now you see the limits of ad hoc testing. You make one change, you fix one bug. How do you know that you didn't cause 50 other bugs? That's where formal unit testing comes in. It's called regression testing. How do you know that you did with that, fixing that one, like 99 tests pass, 1 fails. You fix that one, and the other 99 now fail, right? If you were doing this ad hoc, good luck. You're going back and doing 100 things every single time you make a change. But if you have a formal unit testing framework, all you have to do is hit a button, and it does everything for you. Negative 1, 2, 3. Yay. So I'm pretty sure that it works. In fact, we can, let's optimize this code a little bit, right? There's a principle called the DRY principle, dry principle. Don't repeat yourself. I repeated myself here and here. Well, if it's an if and an else, then it shouldn't be anywhere. Right? Don't repeat yourself. Should I have an empty if statement? Probably not. How could I rewrite this so that I only have one statement? There. That's even better. Right? Now, is there anything else that I could do? Oh yeah. Oh, you're right. Did I hard code it to 0 before accidentally? Okay, I should have been 1. That's where I'm screwing up. Undo, 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 undo. Undo, undo. There we go. Has 1 digit. And then I can get rid of that. There we go. Digit. There. Not pluralize it. Okay. Maybe we're stuck with it because it is completely different formatting. There's no way for me to go from digit to digits without some fancy code. But you get the idea. Right? I guess I could have this. Now that's a catch-all. Again, DRY, don't repeat yourself. If you have code, that's the whole reason that we write loops to begin with. You don't copy, paste, copy, paste, copy, paste for 5 times, right? You write it once and then you make the code repeat instead. All right. So why did I immediately run to a while loop? Why did you suggest a while loop? Yeah. Sometimes they're 4, sometimes they're 5. If I knew it up front that there were 5 digits, would I have to write a for loop at all? Or would I have to write a loop at all? No. So in this particular case, we didn't know up front how many iterations it was going to go for. Let me go ahead and just put this in the notes for you so you have it, if you want it. There we go. Likewise, a for loop, or in contrast, a for loop is good if you know how many iterations you're going for. If it's 10, or even a variable, say n, I'm going to go for 100 iterations, or I'm going to go for n iterations, and n is stored in a variable. Okay? So some common pitfalls here, very similar to the pitfalls with conditionals. This is C code, so let me come over here. Hopefully it's not crashed. Yep, it has. We'll go ahead and redo this. While we're waiting for that, let's take a look at the code over here. Look real hard and tell me if you see anything wrong with this code.
Oh, there's a semicolon.
Yeah, there's a weird semicolon here, right? You'll be able to see this once you've got your eagle eyes on you for code. Like there's something seems out of place. Let me go ahead and cut and paste that and move into that directory. And what should I be doing to catch that? The wall flag demo. There we go. Remind me later. There we go. There we go. The while clause does not guard, just like the if clause did not guard. If I didn't use the wall flag, it probably would not have warned me about that. What is the consequence of that code? Let's think about that. I is 1. While I is less than or equal to 10, do what? Nothing. It just must be a really complex problem that it's running. Right? I'll wait another 5 minutes for it. Another 10 minutes for it. What's it doing? I is 1, do nothing. I is 1, do nothing. I is 1, do nothing. Let's kill it. And the fix is making sure that you don't have that semicolon there. Now, while I is less than or equal to 10, we'll print it out and increment it. And now this will actually run. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So the solution, and by the way, can you even do this over in Java? Let's find out. System.out. Put that semicolon right there. No warning whatsoever. Right? Thanks, Java. Right? Once again, it'll do nothing. You don't see that it's actually doing anything, so maybe it's just thinking really hard. No, computers don't think. It's just not doing anything. All right. All right. Again, use a proper linter tool, the wall flag. Here's another example. I is equal to 0, while I is strictly less than 10, do the following. Yeah.
Here's
No increment operation. Right? So what will this end up doing? Infinite loop, always prints 1. Right? In other words, you always need to be making progress towards your terminating condition. Right? If you're not making progress towards your terminating condition, you're just going to keep on going. Right? Here's another one. I is equal to 0, while I is strictly less than 10, print it out and increment it. Those of you coming from a Python background will think, oh wow, that's actually how I would write a while loop in Python. Oops, not there. There. Except that I would need a semicolon here, and I wouldn't print it out, I would print F, and I would do something like this. I. There we go. There's perfect Python, except that you can't do that, so I plus equals 1, and I don't have a declaration like that. There, that's perfect Python right there, right? Undo, 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 undo. Right. And system.out.print. Perfect Java. 0, why? Was there what? One line here, right? This while loop, while I is strictly less than 10, do only the very next one thing, which is print it out, right? It's not actually, even though you're indenting here, it's not like Python where indentation matters. There, that's the correct way of doing it. Always write your, clear this out, opening and closing curly brackets, even if you don't need them, right? Because it's best practice. It's best style to do so. If all I was ever going to do was one thing, you don't need the opening and closing curly brackets, but it looks weird, it looks horrible, it's bad style. Right. Oops, there we go. Good? So, again, you forgot the curly brackets. It's bad style. Infinite loop. The best practice is to always have your curly brackets. Here's one more. All right. I used to be able to ask this question and nobody would know what a Zune is. But ever since the Guardians of the Galaxy came out, now people know what Zunes are. So what's a Zune? Oh, okay. It's an MP3 player, right? The joke was that he got the Zune. He had a Zune instead of a. Maybe you watched that and you thought it was just a made-up thing from the Marvel universe. No, it was an actual Microsoft product. It was a competitor to the iPod, right? Say what? They found it with the dinosaurs. Wait, what? What do you mean? Oh, okay, okay. No, is that a joke from the movie? Or no? Okay, all right. Anyway.
I think the joke was that he thought that he was mind blown that instead of just having a few.
Oh, okay, yeah. Like instead of 8 tracks, wow, this is a Zune. It fits all this music, right? Well, yeah. Like you're in an interstellar spaceship, dude. Come on. All right. So anyway, a phenomenon happened on December 31st, 2008. Every Zune froze for exactly 24 hours, after which they all started functioning normally. Right. Here is the actual code that was in a subsystem in the Zune. Right. So tell me about, now having gone through Lab 3 or whatever, Lab 3, tell me about 2008. It's a leap year. December 31st in a leap year is which day of the year? The 366th day of the year. So 366 is strictly greater than 365. Is it a leap year? Yes, you already told me. You wrote this function too, right? And by the way, why is it a capital I? That's a Microsofty thing. Right? That's upper camel casing for function names. You'll see that if you ever do any C# programming. It's really weird, and it's only the only language where that style is used. Anyway. If days is strictly greater than 366, is it? No, it's the 366th day. So does this get executed? No. What is it trying to do? It's trying to reset it down to the first date, or 0 day, and then it's incrementing the year to 2009. But that doesn't happen because of strictly greater than. Right? This was true, so this does not get executed. What do? Come back right up here. It's still the 366th day. Right? We repeat. Now you see why they froze for 24 hours. Because what happens on January 2nd, 2009? It becomes the 367th day. That is now strictly greater than 366. We update this. We update now the year is 2009, and we break out of this loop. So you see, again, it's not like building bridges where you can omit one character or one bolt and you're still fine. You omit one character here and you've got literally hundreds of Zunes that were purchased. I had a Zune and I experienced this. Right? This is why I've incorporated this ever since.
Did you know why it was happening at the time?
Afterward the fact, right? But think about what happened, right? 24 hours, well, okay, so what? They can't listen to their music for 24 hours. Not that big of a deal. But as far as Microsoft is concerned, they had to go into emergency mode. They had to pull in many, many people. They had to have many billable hours of work just to deal with this one bug, right, in a panic. Right? That's a lot of money, right? I don't know how much, but you can quantify that in terms of wasted hours. Like everybody had to drop what they were doing for so long and then report this, right? That's a pretty innocuous, and I don't have the list of it, but that's a pretty innocuous bugs, right? There are some stupid bugs, though, throughout history that have led to catastrophes. 2 Mars rovers, before any of you were born probably, 2 Mars rovers, hundreds of millions of dollars were destroyed because of various bugs. One of them was a failure to convert from metric to English units correctly. Why they were doing English units at all was that was the real failure, right? Yeah.
Could you explain why everyone was afraid, like once the year hit 2000?
Oh, so, well, here, if I use an integer to represent the year, 2023, right? There we go. All right. That's fine for now. That's fine next year. What happens approximately 2 billion years from now? 147,999,999. All right. What happens in the year 2,147,999,999? It's out of range, right? Likewise, what they were doing, like the Y2K bug, they weren't using integers. They were using, say, 00. In fact, we'll call that a string so it compiles, right? So in the year 1900, right, that goes to 1900, right? What happens when you reach the year 1999? Well, you're only using 2 numbers now. It's a form of overflow. It's just a different form of overflow. And so what happens when you add 1 to that and it's supposed to be 2000? Now you're back to 1900. Right? And by the way, if you think that was solved, it wasn't. Right? We have Unix epoch problem. 2038. It's coming up. It's coming up. It's only 15 years away now. So we'll have yet another Y2K problem.
Yeah, they just kicked down the road.
Well, no, this is a little bit different because what it's doing is using an integer to represent the number of milliseconds since the Unix epoch, which is January 1st, 1970. That's how Unix keeps time. Right? Now, if they're only using an integer, a 32-bit signed integer, then they can only represent dates up to, what is it exactly? January 19th, 2038. About 3 o'clock in the morning in England. UTC is England time, right? Greenwich Mean Time. So the solution there is use a 64-bit integer. That'll take us several billion years down the future, and then it's their problem. Right? So it's all related to overflow, underflow. It's because time as a concept is infinite, but numbers in a computer has finite amount of memory. There's also a precision problem, right? If you're using whole numbers to represent, milliseconds, what if you need something that's timed to fractions of a millisecond or nanoseconds or something like that, right? Then you're not going to be able to do that. You're going to have to use a different scale entirely. Right. Good questions.
Are these problems something that people were thinking about when they were creating this?
Is it a problem that we're not thinking about those poor people 2 billion years from now?
Well,
No.
That's like 21 times the age of the universe.
You're right. It was definitely a foreseeable. 1970. Come on, you've only got 68 years, right? But you're thinking in 1970. So what? or the year 2000 problem. You're only thinking 30 years in the future. That's somebody else's problem.
Not like considering these problems when they're doing things.
Yes and no. Here's another example. How is the current semester represented? Does anybody know in the UNL system? 2023. So it's a 1, 2023, and this semester started in August. There. That's how it represents semesters, with 4 digits. With the 1, the first one always being 1. In other words, We didn't learn our lesson. Right? And I was here to witness this in, I think that they switched over to PeopleSoft in 2008, and I was pointing out to them, you're just making a problem here. Why are you only using 2 digits to you didn't learn anything from the Y2K problems, did you? Right? Why are you using 2 digits to represent the year? Right? Moreover, why are you using 1 digit to represent the month? This means that you can never start a semester in October. You can never start in or November or December, right? Short-sightedness, right? Get it done quick, right? There's another concept called the iron triangle of projects. You can do it correct, you can do it quick, or you can do it cheap. You can choose at most 2 of those things, right? And so it's always going to be, we'll do it quick and cheap, not correct. Or you could choose one of those things or none of those things. And that's actually far more common than choosing at least 2 of them. But have a good weekend.